So was it too easy? Today's homework was short, wasn't it? Super quick. You want to do the quiz. That'll give me a chance to get set up. So why don't I do that? Quiz, quiz, quiz. Here we are, quiz. By the time I get to I'll start in the middle maybe. That way. There. There you go. Here's a few. Deal with it later. I think there's just one. Maybe more. How about those? Is that up there? One. There's two there. Look at this. You got an extra one? That's amazing. Here, let's just mess that up. There. You got extras? Two extras. Perfect. There we go. Sorry, late last, but there's too many. You got extras at the end. Okay, who needs one? Everyone's got one. It's so exciting. Why did this go black? Hold on a minute. There we go. Come on. All right, I finally got mine up on the screen, and you're probably already done, at least in the middle. So don't rush, though. If you're still working, but if you are done, I'm happy to take a look and see if I can get the same answer as you. Nice work. Good job. Big time. All right, thank you. Here. Your white chocolate double shot. Oops, sorry. Oh, that's okay. It's okay. My knees still work, sort of. You have something you can answer. Why do you have a question mark? Why do you make answers? No, I thought we were over this last semester. We went through this. Okay, I think I've got all of the. Do I have all the quizzes? Anyone holding out on me? Okay, let's staple these together so that they can all be happy. Okay, so the answer is, let's see if I can get this right. I multiply those two numbers together, 10,000 times 0.01, I get 100. That's supposed to be 100. And then I do 1,000 times 0.1, and I get 100. And then I do 0 times whatever, and I get 0. Add them up, and I get 200. Question mark? Oh, yes, it is 200. Sorry, a couple of you were like, what is it? And it is 200. You were right. It is that easy. So make sure you don't doubt yourself when you come to the test in 2 weeks, because it will be that easy. Okay, so today, though, we have to do something hard. I know it seems unusual to have to do something hard in this class because we've had too much fun lately. So give me a sec. I got to get this chosen. Implicit differentiation, apportionment. Here it is. This is the thing we have to deal with, standard deviation. Man, we went right from winter to summer. Just a minute, I got to take this off. So standard deviation is what we have to deal with today. You know about quartiles. Quartiles are just a measure of how spread out your data is. You have the first quarter, the median, the third quarter, and that tells you sort of how spread out things are. Standard deviation is just another way of doing this, but it's in relation to the mean instead of the median. So let's just get to this. There's a formula for this. Before we do standard deviation, I'm contractually obligated to tell you what a variance is. Then we can do standard deviation. So a variance is simply the average of the squared difference from the mean. Oh, that sounds not simple at all. So maybe it would be easier if we actually did an example, because that is not simple. That is not at all simple. So let's go over here and do this to help us to understand what it means to be the average squared difference from the mean. You see, we're trying to figure out how far people are away from normal. Okay, I shouldn't say it that way. How far people are away from average. So how far are you away from average? Are you really far away from the average, or are you not so far? And if the variance and the standard deviation are small numbers, it means everyone's all grouped together in a happy little clump. And then if those numbers are big, it means everyone's spread out really far. So with this cheesy example, the first thing I need to know is I need to know what is the average. What's the average of those 6 numbers? I'll bet you can do this. It's not that hard. You could use X bar if you don't like, oh, actually, wait, where'd my bars go? My bars are missing from the X's. Okay, yeah, let's use X bar, and I will fix my X's here in just a sec. There we go. So X bar, compute that while I fix the X's. X bar, here it is, X bar. Okay, that better? It's still not very good. It's a little better. Yeah, you can see the bar now. Okay. And here we go. Just got to get the right app. Got distracted by the B-reels. Okay, so Hayden, how do I compute the average? Okay, you add them up. I'll divide. Did you add them up? 60. Okay, so add them up. And there are 6 numbers there. Wasn't that clever of me? Make it easy for myself. Usually I'm not that kind to you guys when you take your test. But anyway, there's the average. It's 10. And so I'm going to use that average to compute the variance. The variance is the average of the squared difference between each of these points in the mean. Let me do the first one for you, and then you'll do the rest. So 2 minus the mean is -8. And then when I do -8 squared, I get 64. So far, so good? Now, at first, you might say, why are we making this extra complicated by squaring this? You'll see in a minute. But for now, just blindly follow along and do the thing with the chart. It'll make me feel better. Well, I know what you're thinking. I didn't give you enough time. It's okay, because we're going to do this together. Kieran in the back. What is 5 minus 10? -5. Very good, very good. And then Emma, do you know what -5 squared is? 25. Excellent. So you see how easy that is? You can almost do it in your head. Let's go on. Liberty, what about 10 minus 10? Okay, that one's the easy one. And then I won't even ask. It would be insult someone's intelligence. 0 squared is 0. Oh, I should have asked because someone might not have known that. Did you know? 0 times 0 is 0? Okay. Whew. Okay, anyway, Adric, do you know what do you know what 14 minus 10 is? Yeah, and do you know what 4 squared is? Good job. You see the pattern. Zoe, can you do the last one for me? What's 18 minus 10? And what's that squared?
60.
Perfect. All right, so here's the deal with the squaring business. If I was to just average together these numbers, you'd get 0. I mean, check it out. -8 plus -5 plus 0 plus 1 plus 4 plus 8. All those together is just 0. That happens every single time you make a chart like this. You always get 0 if you just do that. And so we need to have some way of describing how far people are away from the middle. And so the way we do it is we square these numbers, and that takes negatives and makes them positive so that we can average those together. Now I've got a little bit more of a challenge, and that is to average those things together. 64 plus 25 plus 0 plus 1 plus 16 plus 64 divided by 6. Ugh. What's this? 128. 130. 144. 145. 170. 170. Okay, so 170 over 6, which is about 26.67? Or is it, am I off by 1? How far am I off?
28.
Really? Wow, I need to get my brain checked apparently. 28.33. Well, at least I got the 170. Okay, so that's called the variance. That is the variance. Variance is equal to 28.33. What does it mean? I don't know. Let's go back to the formula. So it's just a number. Okay, it does have meaning, but it's not as meaningful as the next number. But we needed that in order to get the next one. The next one is called the standard deviation. Find the standard deviation. And so standard deviation is the square root of the average squared difference from the mean. So standard deviation is just the square root of the number we just computed. So we've already got this. It's not that hard to come up with the standard deviation. So let's go ahead and do that. The standard deviation, which we use a little sigma to represent. Standard deviation, sigma. So sigma, little sigma. It looks like an O with a little tail on it, like a cursive O. But anyway, so put an O there and with a little tail, and that's going to be the square root of 200 or 28.33, and that's what, 5.2? Okay, 5.3. I'll give you the extra one. 5.3. Now that does have some meaning. That tells us, I mean, this does mean something, but notice what we've done. We did the average of all the squares, and then we took that and we did the square root of that. And so essentially we got rid of the fact that we squared everything. So this is a little bit more of an accurate description of how, on average, how far everyone is away from the middle. Now, just to illustrate this, I looked up a few averages and then I fudged them just a little bit. So just so you know, if you look this stuff up, it's not going to be what I have here exactly if you go to the CDC website, but close enough just to make it more interesting. I thought I'd do this. So heights. Guys, in America, we have an average height of 69 inches and standard deviation is 3.5 inches. Girls, it's 64 inches with a standard deviation of 2.5 inches. So notice what this does for us is it allows us a way of comparing two people from two different populations to see who is more unusual. Specifically, I could ask the question, how many standard deviations are you away from average? Myself, I happen to be exactly 1 standard deviation away from average. So I'm not very unusual. You might say, well, how tall are you? Well, I used to be 73 inches, but I have shrunk in my old age, and now I'm 72.5 inches. And if you do 72.5 minus 69, you get 3.5, which means I am exactly 1 standard deviation above average, which isn't all that impressive, to be honest, because I'm sure a number of you are in the same boat as me, and some of you are even more unusual than I am. But you could do the same thing. So let's see, my wife is 69 inches tall. 69 inches is 3 inches above average for women. Wait, 69 inches is 5 inches above average. Got to get that brain scan apparently. So 69 minus 64 is 5. Wow, that is 2 standard deviations. I think I may have fudged the numbers a little bit too much for this particular exercise because I don't think she's that unusual, to be honest. But that is 2 standard deviations, whereas I'm just 1 standard deviation above average. So in a sense, even though my wife is shorter than me, she is much more unusual, much more unique, which I knew that a long time ago. But so 2 standard deviations above average. You could do the same thing. Yeah, I think I may have massaged the numbers a little bit too much. I didn't mean for it to be quite like that, but anyway, I'll get the actual numbers when it really matters. But you could do the same thing for yourselves. And this gives us a sense of where most people fit. In fact, most people are going to be within 2 standard deviations of any average. So if you're within 2 standard deviations of the mean, you're relatively normal. I hesitate to label things as such, but it's relatively, you're typical. Typical is a better way of saying it, because we know that none of us are really normal, are we? Maybe you could be. I'm definitely not. Shoe size, just to give you another one, and here again, I did my best to look this stuff up, but actually I couldn't find standard deviations for shoe size. I just found the average. This is US shoe size, so don't give me your UK shoe size. Take your US shoe size. I happen to be, well, you know what? You know how I got shorter over time? My feet have gotten bigger. So I used to be a size 12. I find that a size 13 is way more comfortable nowadays. So I don't know what happened there, but I guess it's all gone down and out or something. But so let's say 13. So 13 for me, 13 minus 10.5 is 2.5. So I'm 2.5 shoe sizes above average, which is not quite 2 standard deviations, but it's getting there. I have a son-in-law who's shoe size 15. He is well above I mean, this is way up there. So he's got 4.5 inches, which is 3 standard deviations above average. That's massive. And he has trouble finding shoes to fit himself and has to go to special stores. I'm sure that there's maybe one or two of you who have a similar issue. But anyway, this just tells us how spread out a population is. Most people are going to be within 2 standard deviations of the middle. So that's what we use this for. We'll use it quite a bit, but for now, we're just going to compute standard deviation of probability distribution. So we just did that here for this situation, but we're going to do the same thing, but for a probability distribution. So you might wonder, well, what's the, why would you care about a probability distribution? Well, understanding the standard deviation of a probability distribution, that is something like this, will give us a feel for how spread out randomly chosen things from this distribution could occur. So this is the probability distribution for the number of boys or girls. You can choose which one you want to be interested in more, but the number of, pick a gender, in a family with 3 children. So without showing you all the details, there is a 1/8 chance if you go set out to have 3 children, let's say, there's a 1/8 chance that you will have 3 girls or 3 boys. Yeah, let's make the boys zeros, okay? So 3 boys meaning 0 girls. There is a 3/8 chance that you will get 1 girl, 2 boys. There's a 3/8 chance that you'll get 2 girls and 1 boy, and a 1/8 chance of getting 3 girls. So here we could do the same thing that we just did, but we're doing this for this probability distribution, but the probability distribution mimics society at large. If you take all the families with 3 children, we can basically describe the standard deviation and the mean for those people using this chart. So first chore, your first job is to compute the average. So do you remember doing this? Whoops, I have mu bar. That doesn't make any sense. So we did this a couple of days ago. Wait, did we just do it? Oh, we just did it. You did it on your quiz, but we did do it a couple days ago. So go ahead and compute the average for this because we're going to need that to be able to compute all the rest of this mess. So just take those, multiply them together, 0 times 0.125, 1 times 0.1375, etc. Add them up. Whew. So take a minute, go ahead and do that. I will wait patiently and wish I was outside. It's nice out. Well, Jonathan, I think you've already done it, haven't you? You got something? Let's hear it. Let's hear what you got. 0.375 times 1, that's right. All right, so you're doing it a little bit at a time. That's not the actual mean. So let me write this down. 0.375 times 1. And you can skip the 0 times 0.125 if you want, or you could write it down. That's fine. And so what else do I have to multiply together? So there's this times this. You weren't quite done. I see. You just had done the one part.
Oh, right.
Yeah, keep going, man. Multiply it all. Don't just pick one of them. All right, well, Jonathan got us going. Easton, did you finish it up?
Yeah,
What do you got?
the last one is 0.375 for the 3.
Oh, I see. There's an error in the, yes. Okay. Oh, okay. Yeah. Okay. So to get the average, when you have a probability distribution, you don't have to divide. Yeah, you just add them up and you're all done. Sorry,
Okay.
sorry, Jonathan.
One
I take you did it all, and then you did one step too many. And Easton decided to do that one step too many as well. Yeah, when you get done adding all this up, because it's a probability distribution, kind of like on your quiz, you just multiplied and added. And some of you chose to put a little question mark next to it because you're like, could it be that easy? Yes, it is that easy. Multiply and add 200. You remember that one? So here, this is 1.5 is the final answer. So think of it this way, that on average, if you look at all the families of 3 children in America or in the world, on average, you will find that they have 1.5 girls, 1.5 boys. Kind of makes sense, right? On average. I mean, no one has a half of a girl, but you could imagine that. Okay. So we've got the average. Okay, now we can do this. And so this is a probability distribution. So let me just make sure I emphasize this, that we're dealing with probabilities here. Back here, we were dealing with actual raw data. We're not going to deal with data, at least not in this form. This is actual data, whereas these are probabilities. So we're just going to do probabilities today. I know I just did data, but I wanted to make sure that you understood where the numbers were coming from. It's on me. It's my fault, Jonathan. I'll take responsibility for that. Okay, now that we've got that, the rest of this is very similar. I've got my chart set up to try to help you work through this quickly, but let me do the first one for you. So the first thing I'm going to do is I'm going to do the outcome minus the average. So that's going to be 0 minus 1.5, which is negative 1.5. After I've done that, I take that number and I square it, 2.25. Then I take that number and I multiply it back by the probability. You see, when you multiply by the probability, that's, I see a bunch of people gonna yell at me. Did I mess up? What did I do? Why is nothing showing up? What in the world? Okay, just a sec. Huh, that's weird. Never had this happen before. Maybe I just need to, here, just a sec. Thank you. Thank you for reining me in because I've been known to do dumb things. Let's see. Huh, that's weird. Hold on a sec. Uh-oh. Oh, you know what it is? Just a sec. If it's this, then you're going to hear me complain about something. I know you're looking forward to it. Just a sec. Wi-Fi. It's this. You know what that is? The login. Sorry. You would think that they could not kick me off the network in the middle of class. But anyway, it happens to me once a month. So you know what's going to happen? 1 month from today, that's going to happen again in this class because it's always a month like, oh well. I can't fix it because I am not in charge, sadly. Where is my, why can't, now I've got to redo everything. Hold on a minute. What in the world? Sorry. It's being super dumb. Here we go. Oh, come on. Come on, buddy. Bring it. Yes. Okay, sorry about that. Thanks for letting me know, though, because I don't always know what's going on back there. No, it's back behind me. Okay. All right, we're good now? We got it. Thank you. I thought that I might have made a mistake, which it was not my mistake. It's the motherboard for kicking me off once a month. It's going to be all right. Yeah. Does anyone work for motherboard here? Okay, good. I was going to say, you don't have to tell your bosses that I'm complaining about them in front of students. But anyway, getting back to this. So you take x minus the average, and then you square that, and then I multiply that times the probability. So I've got 0.125 times 2.25. And that's going to be a little bit more than 0.25. I can't do that in my head. So we'll just have to, I'll get that in a sec. I'll grab a calculator. So your job is to finish filling out. There's 3 more to do. 3 more, you can do this. And actually, there's not really 3 more. There's actually 1 more to do. You'll see what I mean if you try to do more than 1. Three, 8. Well, if you're not done, it's okay, because I just need the next line, and then we'll be pretty much done. So let's see how we're doing on this next line. We got Carson. What is 1 minus the mean? Yeah, negative 0.5. Very good. All right, Shelby, can you square that number? 0.25. Beautiful. All right, Grayson. Do you know what 0.25 times 0.375 is? 0.9. Okay, 9.4. It's 9.375? All right. I kind of like the 375 there. But anyway, getting back to this. For 2, oh, yeah. Now we're done, aren't we? Yeah, because for 2, the 2 minus the average is 0.5, 0.25, 0.09375. Does that look right? Awesome. And then this one is going to be the same, not negative though, positive 1.5, 2.25, and then 0.28125. All right, let's add all this junk up. And then we'll have our variance. This is going to be the variance. So take a minute, crank that into your calculators, see what you get. 528. All right, let's see who's got this. Oh, you're not here to do it, but Sam, you are here. Did you add those up? What'd you got? Wow, 7.5. See, if I had rounded them, it wouldn't come out to be such a nice number. So, nice number, 0.75. That's the variance. The standard deviation is the square root of that. And I can't do that one in my head. It's going to be 0.5 times 0.1732, something like that. But let's see. Go ahead and do the square root of this, and then we'll see how you're doing. Riley, what do you think? Did you get a square root of that number? What did you say? Keep going. All the numbers. Okay, good enough, good enough. Yeah. When you do this for your homework, it'll be wanting, a certain number of digits, I think, if it doesn't come out evenly. So just so you know. So this is actually a little bit more involved than the ones on your homework. I thought I'd show you a couple that are similar to your homework so that you aren't too scared about this. So, in addition to this, you have a few problems with averages, but in order to do this, we have to do the average anyway. So this one I actually stole directly from the homework. That's why it looks like it's, I guess, Mount Vernon High School colors. That's red up there. Yeah, it's orange on my screen. But whatever. Go ahead and compute. We need to compute the average. And then we're going to compute the variance. And then we're going to compute the standard deviation. I probably should have left myself some room there, but such is life. So take a minute, work with a friend if you need to, compute the average, then compute standard deviation, or the variance in the standard deviation. Oh, okay. Type the equals first. There you go. I don't know if you're done or not, but let's go ahead and walk through these. If you aren't quite there, we'll get you there. So Emily, you want to get us started on this one, don't you? The average for this probability distribution. What are you going to do? All right, so it'd be like this. XP is 0, 4/3, and 4. And add them up. Very good. So that's perfect. So that's 16/3 is the final total. Is that right? Is that what everyone got? That's 5.33. 5.33. Great. Okay, so there's the average. Very nice. Next, we're going to do the sigma squared, but that's going to require a couple of different steps. So just a minute. I probably should have made this a little bit neater. Here, I'm just going to erase the whole thing and make it neater. So XP, that gave me 0, 4/3, and 4, add them up, 5 and a third. Okay, next we're going to do X minus. Oh, I should have made someone else. That's all right. You know this. Let's do the difference between the outcome and the mean. So Ashley, were you able to do this, the X minus the mean? All right, do you have them all or just so? Okay, but you get, yeah, you know how to do this, right? So you just subtract off, and then the next one is negative, what is that? 5 and a third, so 4/3. And then this last one is going to be 8, 24 8/3. Did I get that right? I feel like that's not right. Something is a rot. Maybe that's right. It's okay? Yeah, it just looks weird. It's like that back row who all of them put question. No, I'm sorry, I shouldn't have said that. There were several people saying question mark after their 200s here. So maybe it's the same thing with me. It's like I look at the numbers, they don't look right. Maybe question mark? Okay. No, we got it right. Good. Okay, so there's that. Okay, so let's find the next volunteer. Clayton, what's the next step? Okay, so I'm just going to square each of these. Now things get kind of ugly, don't they? So let's see. Luke, were you able to square that first number there? You're doing it now. That's excellent. All right, I'll take all but the negative. I don't want any negatives. Yeah, yeah, I know. The calculators are funny about the way that they compute things. Just be careful and just remember that anytime you square a negative number, it becomes positive. Kira, were you able to do the negative 4/3 squared? 7 repeating? All right, that sounds good to me. And then Lila, what about the 8/3 squared? All right, you're doing it though. It's right. Just go ahead. Your calculator gave you that? It's okay. 64/9. You know what? I want to loop back around because I don't like that 28.4089. That's not right, is it? With a 4 repeating? Okay. Oh, I see. Yeah, this is one of the problems with rounding. 64/9 is 7.1111111. Okay. Yeah, if you try not to round if you can. Next week, Wednesday. Wednesday we'll use the computers to do a lot of this. So we'll do the whole computer thing. It'll be like boring for some people and really difficult for others. But the computer just stores all the digits, so you don't have to think about it. The problem is having to write them down. No one wants to write. Okay, so there it is. Almost done. Next step, we've got Libby. What is the next step that I'm going to do? Okay, we're going to add them together, but we're going to wait until we do the next step, and then we're going to do Libby's jumping the gun just a bit. So we are going to add something together, add them up. So add together. Almost done though. So very good. But Ty isn't here. He just decided to. I thought I must have offended him. Noel though. Noel, do you know what we do just before we add them all together?
Multiply the, like 0 times, or no, multiply the negative 5.33 times 28.
Something like that. Yeah, yeah. I'll write down the formula up here so that we can follow along. It's going to be P times x minus mu squared. So take the probability, multiply it by, so it'll actually be this times that. So multiply those together. So let me get something here. We'll do that times that. And so if you haven't done it already because you weren't sure exactly what to do, now you know you're going to multiply this times this times this, etc., all the way down. Cooper, did you get that first one? 1/6 times 28.44444? Okay. All right, you can do whichever. Well, yeah, do the right one this time. Let's see who does. Grace, do you? Yeah, you're there. You moved over one.
Yeah.
All right. Do you have that first one?
I got 4.74073.
4.74073. Why not? That sounds close enough. All right, Nathan, do you have the second one? 1/3 times 1.77777?
Well, my computer thinks the answer is January.
Okay, January is very close. You could always use your calculator. Let's see if I can find another volunteer to do this. Alyssa, do you have this 1/3 times 1.77777? 5, 6, 3 repeating. All right, I'll go with that. That sounds reasonable. Okay, last one. We're almost there. You're not here, but I'm sure you could do it. But Elisa, did I say that right? I keep messing up, but what's that last one? 7.111 times 1/2. All right, we'll go with that, 3.555. Now we just have to add these up. So just what Libby suggested, we're going to add those 3 up. And let's see, I'm just going to do it pretty quickly in my head. 3.55, 0.56, add those together, you get 4.1 approximately. And then add that to 4.75, 4.1, 8.85. So about 8.85, about. This is totally in my head with the decimals. So approximately. You'll want to be a little bit closer to the actual answer before you do it on the for this. Okay, so let's pull this over here so that we can enjoy looking at this together. So you're going to have 3 separate sets of things to do for Monday. So one of them, the first 2, if you want to get to the stuff we just did, that's in the 3rd one. The first 2 are going to feel like reviews of what we did on Wednesday. They probably should have been lumped in with Wednesday's stuff. But the stuff that we just did is going to be in that 3rd one. So you'll see things like this. I just wanted to, oh, look, that's almost exactly like what we just had. That one's boring. Hold on a sec. Let's pick another one. Okay, that one's a little bit more interesting. It's got 4 answers. But still, similarly boring. It's pretty straightforward, pretty simple. So that should be straightforward. Let me remind you, free date night tomorrow night. You can go to Kenyon. By the way, another free date is if you're looking for something to do. There's lots of hiking trails around here. If you're not sure where they are, let me know. I will direct you to some beautiful trails. You can bring your special friend and maybe even propose to them. I don't know. Okay. I'm going to stop the recording so that if you want to tell me about that proposal,